Hi guys, welcome back to Nat 5 and 5, and we're going to do more trigonometric graphs, and we're going to be looking at graph translation or a shift in the y direction. So we've already looked at this number in front of the sine and the cosine, the amplitude. We know what that means now. We know the number in front of the x means how many cycles are within the period of 360. So today we're going to be looking at this, adding or subtracting a number at the end, what this does to it. So let's get started. Now we've seen this sine graph many a time now. We know what the sine graph looks like. This is a sine graph. We know, when it goes up to 1 and down to -1, so we've got an amplitude of 1, and it's got a period of 360. So I'm just going to just quickly look at every point. So here you can see my little square here that I'm moving about. If your x is 0, got a wee table of values here, your y is also going to be 0. I take another wee square here. If my x was 90, what is my y going to be? My y is going to be 1. Okay. When my x is 180 is on that x-axis there. Just label that x and y. And my y is obviously 0. When my x is 270, my y is -1. And when my x is 360, again it's on the x-axis, so my y is going to be 0. Okay, so just look at those points there. I'm going to look on, do the next table of values here. So you can see that you've got y equals sine x, which we've just done up here. Okay, exact same as that there. Only it's got something extra at the end. It says add 2. So we've already worked out what sine x is. So all those values that I've highlighted on top, all I'm going to do to them is add 2 to them. I'm basically adding 2 to all these numbers here. So it becomes, so 0 add 2 is 2, 1 add 2 is 3, 0 add 2 is 2, -1 add 2 is 1, and 0 add 2 is 2. Okay, so I would take each of them now and then plot them. So again, this means 0 along and 2 up. So 0 along, 1, 2 up. This one means 90 along and 3 up. So 90 along, 1, 2, 3 up. This one, oops. What have I done? Sorry, I don't know how to manage that. Okay. This one here is 180 along and 2 up. 180 along, 1, 2 up. This one, 270 along and 1 up. 270 along and 1 up. And the last one here, 360 along and 2 up. So 360 along and 1, 2 up. And you can see, again, it's going to be in the shape of the sine graph. So what has happened to it? So I'll just draw on the sine graph there. That's obviously a 2 there, and now that's a 3 up there. So what has happened to it? So this 2 at the end has caused it to move up 2 places. So it's doing exactly what you think it is going to do. It has moved up 2 places or 2 units in the y direction. So I'm just going to write here, shifts up 2 places. Okay, so before we start this next one down here, this is y equals sine x, take away 1. So think about what that is going to do to it. So again, you've got your values for your sine x up here. Again, the ones that's highlighted at the top. And you're just going to take 1 away from them. Change the colour of my pen. Okay, so you can take 1 away from these ones each time. So what is your values going to be? So it's going to be negative 1, 0, negative 1, negative 2, and negative 1. So we just plot them. So you've got 0 along and negative 1 down, 0 along, negative 1 down, 90 along 0, 90 along 0, 180 along negative 1, 180 along negative 1, 270 along negative 2, 270 along negative 2, and that last one there, 360 along negative 1, 360 along negative 1, and then I'm just going to draw in my sine graph. Okay, so again, should be able to see what has happened here, and because of this negative 1 here, it has shifted down one place. It shifts down one place. Okay, let's look at the next slide. If they ask you to draw y equals 3 sine 2x plus 1, what is that going to look like? So, let's look at just y equals sine x first of all. We all know what that looks like. So y equals sine x. There's my sine graph, up to 1, down to negative 1. That's 360 there. Okay, we all know what that looks like. What if I now take into account this amplitude at the beginning? So I want to now draw y equals 3 sine x. So it's going to stretch y direction. So still got a period of 360, but now goes up to 3 and down to negative 3. Okay. Now I'm going to look at this 2 in front of the x. So that means there has to be 2 sine graphs within the period of 360. So 1, 2. Pretty good there, is it? Okay, so 0, 360, that's 180. It's still going up to 3 and down to negative 3. So I have now drawn y equals 3 sine 2x. So I'm getting there. Okay. So I have drawn all of this part now. 3 sine 2x. The only thing left to do is this add 1 at the end. And we all know what that means now. It means it shifts up one place. Okay, so in the y direction shifts up one place. So if I just draw this again. Looks something like this here. So it did go up to 3 and down to negative 3, so it moves up one place. What does that mean now? It means that's going to be 1 instead of 0. It's not going to be 3 at the top, it's going to be 4. It's not going to be negative 3 at the bottom, it's going to be negative 2. I'll just go through this a wee bit here. Okay, so your y equals 3 sine 2x plus 1 will look like that there. I'll just write that in. Y equals 3 sine 2x plus 1. Okay. And can I just show you something before we go to the next slide? When we know that this one's got an amplitude of 1, it goes from the 0 up to 1 and from the 0 down to 1. So that means it's got 2 units. So if I take that 2 units and divide it by 2, half it really, I get an amplitude of 1. So if I look at this one here, it's got 4 and negative 2. So what's the difference really between 4 and negative 2? So from the 0 goes up to 4, so that's obviously 4 places. And from the 0 goes down to negative 2, so that's 2 places. So in total the difference would be 6. And if I half that, I'll get an answer of 3, which is the amplitude. So look at that in a wee minute. The next slide. Okay, this one here says find the equation of each graph, and that's what I was kind of getting on about in the last slide there. So we want to find the equation of this graph. So it's a sine graph, certainly a sine graph. It's got a period of 360, so there's no extra cycles within that period of 360. And let's have a look at the amplitude. So at the moment the maximum value is 4 and the minimum value is negative 2. So in order to find that amplitude, I'm going to find the difference between that and then half it. So from the 0 up to the 4, obviously goes 4 places. And from the 0 down to the negative 2, obviously goes 2 places. So in total, there's a difference of 6 there. So if I half that 6, it gives me an amplitude of 3. So there's been a shift in this graph. Before it was shifted, the graph would look like this here. It would have went up to 3 and down to negative 3 in a period of 360. So at the moment you know the graph, that graph there is y equals 3 sine x. But what has happened to it? So when I compare my maximum value of 3 in this graph, because I know my amplitude was 3 before my shift up, it now has a maximum value of 4. So it has obviously moved up 1 place. So here I'm just going to add at the end, add 1. And that is the equation of, sorry, I should really write it over here, because it's this one, it's not that one there. That one's just y equals 3 sine x. Okay, let's have a look at the one at the bottom. Again, let's have a look at the difference. So the maximum value here is 8 and the minimum value is negative 2. So from the 0 up to 8 is obviously 8 places or 8 units, and from 0 down to negative 2, so obviously 2 places or 2 units. So add them together and you get an answer of 10. And if I half that, I get an amplitude of 5. So my amplitude should have been 5 before it was shifted. So a sine graph here, 0, 360, 180, up to 5, down to negative 5. So my graph was y equals 5 sine x, but then something happened to it. So let's have a look. The maximum value here was 5, and the maximum value now is 8. So what has happened? It has moved up again, but it's moved up 3 places this time. So my graph over here is going to be y equals 5 sine x, then an add 3 at the end. Okay guys, hope that was helpful. Thanks for watching, bye now.